Welcome to lesson 4. Today we're going to be looking at while loops. So first let's go back and recap for loops. So for loops reduced unnecessary code and they cleaned up programs. And here's an example of a for loop that prints the numbers 1 to 5. As we looked at before, the second value is 6 because it means numbers up to 6 but not including 6. So now let's look at the code equivalent with the while loop. It's the same program printing numbers from 1 through 5. So we can start by defining a variable x and then using a while loop. So this is the basic syntax of a while loop. While x is smaller than 6 and then a colon. So this is basically the syntax of a while loop, and it's straightforward and simple as it seems. So as long as x, which is this variable we've defined here, is smaller than 6, it'll print x. And then each time it will increase x by 1. So x will first be 1, it will print, increase it to 2, then loop again, print, and so on until 5. And it stops when x equals 5 because after printing 5, it adds it. X becomes 6 and then the loop stops running. So the while loop can also operate using booleans. So it could also be while true, print x, and then that would print for infinity until that true turns to a false, or the loop is broken. So why do we use two different loops? So we use the for loop when we know the number of iterations that we want, such as using the range function where we define the number, or we know what we want to go through, such as in a list where we want to go through each of the elements. However, in a while loop, we want the loop to infinitely repeat for any given situation, and the number of iterations are not known. It simply repeats until a certain situation is satisfied or not satisfied. So let's take an example of a while loop, counting the digits in a number. So what we want this program to do is count how many digits there are in each number. For example, 6 has 1 digit, 37 has 2 digits, and 420 has 3 digits. So how do we do that? We don't know the number of digits in advance. That's why we use a while loop instead of a for loop. And what we can do to get the number of digits is keep dividing the number by 10 and stop the loop when the number is equal to 0. So what we do is use the quotient operator. What this does it divides by 10 and it rounds down. So if we do 25 divided by 10 using the quotient operator, it'll become 2.5 and that'll round down to 2. So when there's anything with a 0 point and then another decimal value, that'll round down to 0, so that'll be when the loop stops. And we also need to keep a count variable that'll let us count the number of digits. And to do that, we need to initialize it to 0 before the loop and then increment it one by one inside the loop. So with while loops, we use comparison operators a lot, and one of these will be needed in this situation. Firstly, we have the equal to operator, which is the two equal signs, one after each other. And this is different from the single equal to sign because that is used in an assignment statement. For example, assigning a value to a variable. However, this is an operator. Next, we have the not equal to operator, which is an exclamation mark followed by an equal to sign. And the greater than and less than operators, which are denounced by their respective symbols, and the greater than and equal to and less than and equal to operators, which is the greater than and less than symbols, both followed by an equal to sign. So feel free to pause the video right now and try to complete this. Feel free to pause the video right now and try this exercise, or keep watching as I'll explain it. So this is the solution. We first have a number variable up here with the number we want to see, And as I said, we initialize a count variable to 0 at the start outside of the loop, and then we go into the while loop. So while the number is not equal to 0, since we know with the quotient operator, as it divides by 10, the last division will end in it equaling to 0, so that will cause the while loop to stop. So what we can do is, as soon as the while loop starts, we increase the count by 1. So for example, in this case, it counts the second digit. Then we set the number to the number quotient of 10. So this will become 4.2 and rounds down to 4. Then it goes through the loop again. The same thing happens. The count is now 2, and then we take the quotient, which becomes 0.4 and gets rounded down to 0. So the loop stops. And the output of this would be the number of digits is 2. So let's look at another example using the break statement. So in this one, we have a 10-digit number, and again the count is 0. So the break statement essentially exits the while loop in the middle based on a certain situation. So let's jump ahead of ourselves here. We'll be looking at if-else statements in the next video, but let's jump ahead of ourselves here and go to if-else statements. So we have an if statement here. So if the number is equal to 0, again we're using that equal to operator, then break. So what this will do is, instead of using the while loop to where it continues until it continues as long as the number is not equal to 0, we have it continuing, and inside we have a statement that says if the number ever equals to 0, then it suddenly breaks the loop and it doesn't go on to these next two lines in the loop, which is the quotient and the count function. That is it for this video, and in the next lecture we'll be looking at if-else statements and taking a deeper dive into how they work.